So dear students, up till now we have seen about the different types of accounts in Ethereum, then gas, the concept of gas and the transactions. Okay, so now we have to look at the Ethereum smart contract, how it gets executed on Ethereum virtual machine, and the different concepts involved in the background. Okay, so looking at the smart contract themselves here, Ethereum allows or it has multiple languages in which these smart contracts can be written with many different languages, like we have Serpent, Viper, we can have LLL, or the most popular is the Solidity, which you all are aware with. Okay, so Solidity is basically an object oriented high level language, and it is very similar to JavaScript, and it gets executed inside the Ethereum virtual machine. So any of these language, what they do is they compile into a standardized bytecode. So it looks something like assembly language code. So that is a bytecode. So it is a bytecode that runs in Ethereum virtual machine. So let us understand more detail about this Ethereum virtual machine. So just like Java, in Java the developers basically write the Java code in any Java IDE, that is integrated development environment, and then they compile it into bytecodes, which then run and are loaded into virtual machine, which is called as Java virtual machine or JVM. Okay, so behind the scene through a Java class loader, and it gets executed in JVM. The JVM specification describe what is required of a JVM implementation, and it actually ensures the interoperability of the Java program across different implementation and the different underlying hardware platforms which are used. So similarly in Ethereum, the smart contracts and decentralized application, that is the dApps developer, code their smart contracts in an Ethereum high level language, for example Solidity language. Okay, and then they compile them into a bytecode and upload them on blockchain for invocation and execution. So EVM is Ethereum virtual machine is a runtime execution environment for smart contracts in Ethereum. And then this EVM comes with a different implementation of Ethereum client, and each implementation follows EVM specification. So now let us look into what are the different components of this EVM and how it executes a smart contracts. So EVM is it's a simple stack based architecture. When executing a smart contract, it performs all operation, or in technical terms opcodes as defined in EVM code or bytecode. So Ethereum provides three types of space in EVM for the operation to access and store the data. So stack is the one here. Stack, this is the last in first out container with a fixed size and maximum depth of 1024 items, to which the value can be pushed and popped. So each stack item is 256 bits long, and this was chosen to facilitate the particular KK 256 hash algorithm and elliptic curve computations. Then we have a memory here. So this is a volatile memory and expandable word address byte array. Then we have a key value store. So this is a word addressable word array, and it is meant to be used as the long-term account storage for the smart contract. So depending on whether you use the account storage or use the contract may be considered stateful or stateless. So as we have seen that there are two things here. If we have a contract account and we have a contract storage, and for externally owned account we have a another storage. So during the smart contract execution, EVM has access to the incoming messages as well as the block header data. So additionally, EVM keeps a track of the available gas available gas and a program counter during the execution of the smart contracts. So unlike Java, Ethereum smart contract bytecode is uploaded through the contract creation transaction. So instead of some class loader within the virtual machine, all transactions are digitally signed by externally owned account. So let us understand it in more detail that how exactly it works. So all transactions are digitally signed. Digital signature is done by the externally owned account. And when a new smart contract needs to be created, the developer follows some particular steps to get smart contract deployed on Ethereum virtual machine. So the developer write the smart contract in the Solidity and compile it into a bytecode. They use their own Ethereum account to sign the account creation transaction with the bytecode, and they send an account creation transaction into Ethereum network. So basically these steps allows Ethereum to upload the code on blockchain and the creation of the account in the world state through Ethereum mining process. So as we have already discussed, the contract can be invoked by externally owned account or via a transaction, or a contract account via a function call from another smart contract. So we can see here that once the invoke, the EVM will load the contract bytecode into memory, loop through the opcode while checking the available gas, and perform all operation on EVM stack. So during the execution, if there is not enough gas or an error has occurred, then the execution will abort. So it will always check the availability of the gas to perform a particular transaction. So EVM executes around 140 operations or opcode that are divided into 11 different categories. So in addition to smart contract execution, the Ethereum virtual machine also perform transaction between the two externally owned account to transfer ether from one to another account. So in all the cases, whenever there is a transaction which is submitted to Ethereum network as a Ethereum mining node, the EVM and Ethereum client, they perform mining operation and add new transactions to the blockchain. Okay. So this is all is already explained in the TVS diagram.